In this video, we're going to look at text mining from the perspective of supervised learning. There are two major perspectives of text mining, or text analytics, as it's also called. One is an unsupervised learning perspective, which is where text mining is used to understand the text in a data set and to get insights from it. And that is the main goal of the analytic process or project. So that's not the kind of analysis that we're going to look at here. We're looking at text mining from a supervised learning perspective, which is often called predictive analytics. And here we are converting rich text such as documents, email, tweets, or so on into features, that is, into numbers or into categories that can then be used subsequently for for standard traditional data mining approaches. That's what we're looking at here. Now, the main question then is, how exactly do we do this? That is, how do we convert rich, meaningful text into numbers and simple categories? This is called vectorization or featurization of text, turning unstructured text into structured tables. So here's an example of what I mean by unstructured text. I love this movie. It's a sweet, but satirical humor. So someone has a lot of rich content of what they've said about it. The most common approach is called the bag of words approach. And this means a non-semantic meaning, understanding of text. Non-semantic meaning that it doesn't really understand what the text says from a human perspective, but it breaks up all these words and tosses them in a bag. And the emphasis of tossing them is that the words end up being completely jumbled. They lose their order, and each word is considered a distinct word. And you can sort the words based on how frequently each word occurs, but you really lose all sense of sentence structure and how things flow. So the word order, the grammar is completely ignored. And each document, and here one review is a document, so if there were 50 reviews, that would be 50 documents. Each document becomes a row of data, and each word is given a numeric score value. Here the scores are the number of words. Now, you might think that just jumbling words, losing meaning has very little value, but surprisingly, just knowing like how frequently words occur and maybe which words occur with each other can say a lot, and a lot of insight, a lot of meaningful insight can come out from that. So now let's look at more specifically about how, specific ways how words are converted to numbers. So this is called vector creation, and there's different choices of what value, what point value, what numeric value to give each word. The most simple approach is called binary term occurrence, which means basically, does this word appear in a document or does it not? So we'll use a simple example throughout here. There are 3 documents, which are just 3 simple reviews of a book. One is book is good book. We'll keep the grammar simple. We'll say book is good book. Another says is not good book. And third says is great book. So binary term occurrence looks at all the different words that might occur here. There's book, is, good, not, great. Those are all the possible different words that occur here. If you have 500 reviews, you take all the words, all the thousands of words that occur in them, but this is simple. And if the word occurs in one line, you give it a 1. If it does not appear, you give it a 0. So that's simple. That's called binary term occurrence, and it's used to determine if a word appears or not. The main limitation of this, and this is a big issue in all bag of words approaches, is this idea of losing the sense of order. And so for example, book is good book and is not good book mean the opposite things, and yet they both have good, counting with equal weights. And yes, this one has not, but you don't. Do you know if saying it's not a book? Some words in word order are very important. So a simple way to try to conserve the meanings implied in word order is by using bigrams or n-grams. And that means also recording the words that occur together. So with bigrams or 2-grams, in addition to having just individual words, you also add the pairs of words. So here, every time book is occur together, you record that. Every time is good occurs together, you record that. Every time good book occurs, you record that. And here you have good book in that order occurring twice. You have one for each word. But then you also record not good. And so you have the fact that even though this second review has the word good, but it also has not good, and that's the human being can be alerted that the good that occurs there when it occurs in not good actually has opposite meaning. So this is a simple approach, but rather effective in retaining some semantics implicit in word order. Now, another approach to counting, giving word values is term occurrence. So it's not just 1, it occurred, 0, it did not, but counting how frequently did a word occur. So in the first line, book is good book. The word book occurred twice. And so it's recorded that it occurs twice. It's not just one that it occurred at all. And all the other words that occurred once are recorded just once. So this is called term occurrence, and as opposed to binary term occurrence. Then there's also term frequency. And this considers the fact that, well, yes, maybe some terms occur many times. Like if you have a review that's 500 words long and it mentions the word book 5 times, well, does that count as much as a review that's just 10 words long and mentions a book word 3 times? So term frequency looks at the percentage of the length of that document and how many times that word occurred. So it's simply the word count in that document divided by the total number of words in that document. So book is good book. Book occurs 50% of the time, 0.5, is 0.25, good, 0.25. And then is not good book, each occurs once, so that's 0.25. Now is great book, each word occurs once, but it's a shorter sentence, so each one carries a little bit more weight, 0.33. And the idea there is that words that occur more frequently in shorter documents have more weight than those that occur less frequently or in longer documents. Now, this idea of words that occur frequently or not frequently is a little bit in tension. And so there's another approach, a little bit more complex, called TF-IDF, or term frequency inverse document frequency. And I'm not going to get into the mathematical formula there, but I'll say that it basically balances the fact that words that occur frequently, not just in a line, but in the entire corpus, don't add additional meaning, but words that are relatively rare should be given more attention. So that's the general idea. So higher scores are for more frequent words occurrences of a word that is normally rare, and lower scores for very frequent words. So using the TF-IDF formula for this small corpus, book occurs in every single document, and so it has a score of 0. The word is occurs all the time, has a score of 0. And a word that doesn't occur at all has 0. So the word good doesn't occur in every document, so it has a score of 0.1. The word not doesn't occurs in only one document, so it has a higher score, 0.28. And great also occurs in only one document, and the document it occurs in happens to be shorter than the one this one with 4 words, and so it has a greater weight. So TF-IDF tries to balance these things. Now I'll say that in general, the binary term occurrence, often with bigrams or n-grams, 3 grams, or so on, or TF-IDF are the two that are used the most frequently. Because most of the time, you want to know, does a word occur at all or not? And that's binary term occurrence. Or you want to weight the words based on the frequency of the occurrence, and TF-IDF is usually the best way to do that. Now let's consider the advantages and disadvantages of text mining. First, the main advantages are that rich human text embedded in documents and email message and tweets and so on can now be accessed and brought into the data mining process. If you just ignore them, you're losing very important information. Text mining can also capture the speech information from audio and video, so it can bring in these even richer types of data into the data mining process. And ultimately, you can now incorporate emotions and some subjective elements as features for machine learning. It's no longer just objective factors that are typically captured in tabular data, but with text mining, you can try to capture emotions and sentiments, and that very often has an effect in your machine learning process. However, some disadvantages are that, let's not kid ourselves, when you turn a rich document into numbers, you're stripping meaning from its context. You're losing the context in which words were used, the intonation. It can't capture things like sarcasm. And so it's not at all the same thing as human beings actually reading through the text. But at least it can access some things rather than completely ignoring them. Another disadvantage is that text mining does add complexity to a data mining project. It involves some additional steps. It can be quite computing intensive. You need to refine it and clean it carefully so that the text that you're mining actually adds useful meaning. But that said, in many contexts where there is a rich source of human meaning that could help in the business intelligence process, text mining is a very useful tool to bring additional insights rather than ignoring this vast potential source of information.